Hello viewers, welcome to my YouTube channel, and this is our fifth lecture of parallel and distributed computing. So we will discuss various aspects on parallel and distributed computing. So let's start with this our video. So the first question is, what is distributed system and how we categorize and design its design. The question that we try to answer this lectures are: what is distributed system? Why should we bother to construct system in a distributed fashions? And what are the key properties of a distributed system? So in the first part, we shall attempt a definition of the term distributed system and compare it to centralized systems. For a better appreciation of the issues that are involved in distributed system, we will review multiple distributed system that everybody in this class has come across, that probably without recognizing that this is a distributed system. We shall then elaborate on the common characteristics of distributed system. These can be used to assess and compare distributed system. They will also provide us with initial guidelines as to what we should remember what we construct distributed system. And lastly, a summary will repeat what you should remember from this week's lecture. In this slide, so we are discussing distributed system types in Salo 1978. So system involve basically hardware processors, applications and system software, that is known as control, and other applications are system information, that is known as our data. Which of these dimensions have to be distributed for the system to be a distributed system? This is actually question mark, and INSALO requires that distribution is transparent and system users are unaware of the fact that the system is composed of multiple processors. So INSALO's model 1978 is a fairly rigid. A system is a fully distributed system if and only if all dimensions are fully decentralized. And lastly, the full hardware decentralizations include multiple heterogeneous control unit that opposed to a single control unit with multiple processor and multiple homogeneous control unit. Apart from that, control must be provided by multiple units cooperating with each other rather than in a master-slave relationship. So data must be partitioned and or replicated. Each part will be its own local directory. So INSALO definition is too restrictive in our opinion. Technique of distributed system construction should also be employed if only a single dimension is decentralized. So this is our main component: control, data and processor. These are the basic components of INSALO's model. So the basic question is, define distributed system and how we can define it. So we employ the adaptations or definitions of Colores, Dollimore and Kindberg, that is in 2005, of a distributed system. It requires autonomous computers to be interconnected through a network. So each computer has to be equipped with distributed operating system software, which enables the computer to coordinate activities and to share resources in a controlled manner, in a controlled way. And we also require transparency of distribution for the computer users, and they shall not have to be aware of the fact that the system is distributed. So these are the basic characteristics of distributed system: concurrency of component, lack of a global clock, and independent failure of a component. So centralized system characteristics. Today, clarify the consequence of distributed system. We compare its characteristics to those we find in centralized system. So in a centralized system, there is a single component. There is a single component that may be decomposed further. However, its parts, such as classes in an object-oriented program, are not autonomous. So that is, the component passes full control over them all at all the time, and there are no other components, that is no need to provide an interface to the component. But if the component support multiple users, that is known as relationship database, the users share the complete component at all times. So a centralized system runs in a single process. So this is the very important. Centralized system runs in a single process. There is no need to take concurrency control and synchronization into any different an account. So there is only a single point of control. That component is in exactly one state that is determined by the program counter of the processor, register variables contents, and the virtual memory occupied by the process. So last is either the system is running or it is not. The situations cannot occur where part of a system or part of its interconnection have failed the need to recover. So another one is the distributed system characteristics. In a distributed system, there are multiple components that may be decomposed further. So these components are autonomous, that is, they possess full control over their parts at all time. The components, however, have to provide interface to be able to use each other, and there may be components that are used by only some users but are not used by others. So it is then beneficial to have these components residing on machines that are local to users that use them. And a distributed system runs in multiple processors, and these processors are usually not executed on the same processor, but we can say the inter-process communication will involve, and communication with other machines through a network, and different level of abstraction and are involved in during that communication. So there are multiple points of control, but these are not totally independent. So components have to take into an account that they are being used by other components and have to react properly to request. So this is the important things, that multiple points of failure in a distributed system. It may be fall because a component of the system has failed. So it may also fail if the network has broken down. It may also fail if the load on a component is too high, that it doesn't respond within a responsible time frame. So even so, the distributed system is more fault tolerant than a centralized one. Our next slide, that is the examples of distributed system. We now review multiple systems that most of us come across already, possibly without being aware that they are distributed. So this review will provide you the better understanding of a issue that are to be tackled during distributed system constructions. So we are talking about the local area network. Local area network basically contains a number of different computers, workstations, and personal computer provide the front end of the network user. So multiple servers, we can say the multiple servers provide shared services, and one of several networks file servers provide data storage services. So any workstation and PC may henceforth store files on disk maintained by these file servers. A local name server map machine name to the IP addresses, username to user IDs, and group name to group IDs, as you can see in the diagram. And any machine can request a service to resolve a certain name. So one or multiple print servers control the access to shared printers. Workstation and PC have the multiple printing job for them. So another component provide a single gateway. Another provide a single gateway to the wide area network. As a user, you need not to aware which machines provide which services. So name servers provide the information regarding machines by IP address, user's name by user IDs, and group name by group IDs. So local area network can be connected together to form intranets. So this is the actual networking of local area networking. So I hope you guys understood all the things, all the concepts of a distributed system and parallel computing. If you have any idea, you can post on the comment section, and thanks for watching my video.